Okay, simplifying radicals and operations involving radicals. Now, when you have multiplication, okay, within an expression that involves radicals, first thing you're going to do is rewrite them as exponent. Now, there are other ways to do this, but I'm just looking at the whole big picture for this unit and what I think is going to lead to the most success. First off, you're going to write these radicals as exponents. So you make a parentheses for each radical, and you're going to place an 8, and you're going to rewrite that as 8 to the 1/4 power. And 32, because a root 4 is identical to a 1/4 power, so you write that. Then you make your 3 lines, and your bases are 8 and 32. They'd both go to the 1/4 power. That's what that line's for. Now, if your exponents are negative, you're going to switch them down here. We need this middle line for something else. Okay, so you got that much. Now, here's what you're going to do. You're going to circle your fractions, the denominator. Okay, denominator's 4. So you're going to make 1/4 root. Okay, and that allows you then to forget about the 4s. And in the radical, you're going to put 8 to the 1st times 32 to the 1st. But if those are to the 1st power, just drop the 1. 8 times 32. Okay, and then I take 8 times 32, and that is 256. So that's what that middle line is now going to be for. We end up with negative exponents, which we will not on this assignment, but eventually we're going to make a second line to rewrite it down here. Now the last step is to simplify the radical, okay, the 4th root of 256. So I go 4 second caret 256. I got a nice whole number, so I rewrite that as 4, and that's your answer. Put your answer down here, 4. Now the first step, again, with multiplication involving radicals, we're going to first rewrite it. 9 to the 1/3 power times negative 24 to the 1/3 power. Now you got 9 times negative 24. Both of them are to the 1/3 power. Now the exponents, this, I'm going to circle them. This and this are both positives, so we don't move anything around. Okay, that's what I would do. I would circle them up there too. Circle them. Now, they're both fractions, so circle your denominator. We're going to get rid of that 3 if I make a cubed root. And inside that cubed root, I put 9 to the 1st, which is 9, times negative 24 to the 1st, which is negative 24. Then I find that product. Negative 216. Now I come up here and find what the cubed root of negative 216 could be. I'm going to punch it in the calculator first. If it's a whole, if it's an integer, great. If it's not, you're going to have to use your sheet to simplify it. So it's negative 6. That's the answer, negative 6. Okay, now remember, if the radicals don't have indexes, they're automatically 2's. Okay, so we got 3 times 4, and we, instead of putting them in radicals, you write them with rational exponents to the 1/2 power to the 1/2 power. So we have 3 times 4, both those would be to the 1/2 power. Now circle the exponents, none of them are negative, so you don't have to worry about that. Okay. Now they are rational exponents, meaning there's a denominator to the exponents. We're going to get rid of that, and you can as long as you make a square root, and you put 3 to the 1st, which is 3, times 4 to the 1st, which is 4. If they're first, don't write the 1st power. So that's 12. Now the square root of 12, I don't think that's going to be a whole number. Okay? I mean, you can try it. Okay, that's a decimal. I don't want to see decimals, okay? So what we need to do is start dividing into the 12, okay? Then we're we're going to rewrite that in two different square roots. 12 divisible by 9, no, it's divisible by 4, okay? So if you divide by 4, you get 3. So that now becomes 2. So it's 2 radical 2 over 3. 2 whole radical 2 over 3. So that's your answer. Also in your final answer, if it's a square root and you don't put the 2 in, that's fine. Because if there's no number there, it automatically implies that it is a 2. Okay, rewrite these. That's going to be negative 7 to the 1/3 power. That's 49 to the 1/3 power. Okay, so you got negative 7 times 49, both of them to the 1/3 power. Then circle your powers. Now with those fractions, that means you make a cubed root, and you put negative 7 to the first, which is negative 7, times 49 to the first, which is 49. Negative 7 times 49 is negative 343. So I go 3 second caret negative 343, and that's negative 7. Here, I'll put that up here. Negative 7 whole. Makes sense because 343 is a perfect root. It's 7. Okay, so write your answer down here. I'll pause the video and go to the assignment. Do numbers 1, 2, 3, 4. Okay. Now we have a radical. It's all multiplication. You don't see any operators. It means it's 54 times y to the 10th times x to the 5th. Okay, it's all multiplication. When they throw addition and subtraction operators, there's a totally different process you have to use. But right now, it's just cubed. Now, here's how you rewrite your radical. You put equals. You make a parentheses with a 1/3 power, and in that parentheses you put the entire expression that's under the radical, 54 times y to the 10th times x to the 5th. So we have 54 times y times x. Now 54 is to the first power, 1 times 1/3 is 1/3. Y is to the 10th power, so we have to take 10 times 1/3. It's going to be 3 and 1/3 because 10 times 1 is 10 over 3. It's a mixed number. Then 5 times 1 and 1/3, it'd be 5/3, but that's an improper fraction. So I should expect that I'm going to get a mixed number, 1 and 2/3. Now circle your powers. You got 1/3 here. Make two separate circles here. Separate the whole number from its rational, the integer exponent from its rational exponent. Now first we're going to cross out those whole powers, 3 and 1. So I just transfer at the beginning of each line y to the 3rd times x to the 1st, y to the 3rd times x to the 1st. Okay, now I can forget about those. Now, looking underneath all your fractions, they're all 3's. I have all 3's, so I make a cubed root, and I put 54 to the first, which is 54, y to the first, which is just y, x to the second, which needs to be written as x to the second. Now, when you have variables within the radical, you're going to make the radical, and those at the end of the line, your variables stay there, y, x to the second. Now what have I forgot about? Compare this to this, the 54. You transfer that up here and simplify that. So first I try to evaluate it. It's irrational. So I divide and I make it into two radicals. They're cubed roots now. So you need to look at your cubed root list. You got to be looking at the right list, okay? That's a cubed root, so I'm looking at the perfect cubes. So 54 divided, I'd start with 27. Bingo. So I rewrite that as 27 times 2. And the cube root of 27 is rewritten as 3. Now listen, here's what you do with this. That 3 goes to the front of the expression, that 3 does. That 2 stays within the radical. Now, that is the right answer, but it kind of looks crappy. Here, write it a little neater. 3y to the third. If it's x to the first, you just write x. And then the cubed root 2y x to the second. Okay? That's the answer, simplified. Okay, next one. This one's a little bit dicier. You just trust the process I give you. Okay? So you rewrite that radical as a 1/4 power. And you put within the parentheses, it's 625 times x to the third times y to the 18th. Okay, so my bases are 625 times x times y. Then 625, 1 times 1/4 is 1/4. 3 times 1/4 is 3/4. 18 times 1/4 is going to be an improper fraction. 18 times 1/4 is 4 1/2, okay? So circle your powers. So you got a 4th, 3/4, 4, and 1/2. The y to the 4th we just put in the front, so we can just forget about it. That means I have 2 whole factors of y that would not involve any radicals. Now look at those bottoms. You have 4s, so we make a 4th root. And we also have to make a square root because there's a 2, so you need 2 of them. So you got 4s and 2s. So in the 4th root, I put the 625 to the first, which is 625. And I also put x to the third. Now in the square root, I put y to the first, which is just y. Okay. Now, since both radicals contain variables, they are going to be in the final simplifications, final expressions. So x to the third and y. But what about that 625? Well, we take that up here, 4th root of 625. First, I'll caret that. Okay, I got a nice integer. It's 5 because 4th root of 625 is 5. Now, where do you put that 5? That is now out of the radical, that goes in front, okay? So now rewrite your answer, just write it a little neater. 5y to the 4th, 4th root x to the third, square root y, okay? So you have 2 different radicals, a 4th root and a square root. That's fine. Okay, that's an implied 2 there, so we make a parentheses to the 1/2 power, so 50 times x to the 5th. So you have 50 times x, 1 times 1/2 is 50 to the 1/2 power. 5 times 1 1/2 would be 5 over 2, okay, that's going to be an improper fraction, 2 1/2. So circle your powers, you separate those, so x to the second will just transfer over, and then that allows me to forget about the second. Now, the rational exponents, they're both fractions, so we have 2 on both of them, so I can make just one type of root, a square root, and in it I put 50 to the first, which is 50, and x to the first, which should just be written as x. Now that radical has a variable, so we know it's going to be in the final answer, and we just put x, okay? Then I got to simplify the square root of 50, okay? So 50, remember, you're not on cube, you're not on fourth, it's a square root, you got to come to the other side. So 50 by 49 won't work. Divide by 36 don't work. Divide by 25, I get 2. So the square root of 25 becomes 5, and remember I put that 5 in front, and then that 2 stays here. So my answer is 5x to the power of 2, and then the radical with the degree 2, 2x. Once again, if it's a radical is a square root, you really don't have to put that little 2 there, because that automatically means it's a square root. 32 8 to the fifth. So it's to the 1/3 power. And then I make my spiel. So 32 times a to the fifth, okay? Or not fifth, yeah, sorry about that. 1 times 1/3 is 1/3. I got to take, not 5, because I got to take 5 times 1/3. It's going to be improper 1 2/3. Now circle your powers. Remember, those get circled separately. Again, there's no negatives within there. Okay, so the a to the first power we just put off to this up there. And we can forget about the whole of number 1. Look at your two fractions. They both have a common denominator of 3, so that means I can make a cubed root, just one root, and put 32 to the first, which is 32, and then a to the second. So since there's a variable in that radical, the radical is in the final answer. The a to the second nothing happens to that. Okay, so the cubed root of 32. First we'll see if it simplifies. You can always tell if you're going to get a decimal on it, because if 32 is not on this list, it won't work. But 3 second caret 32, got an irrational. So we got to divide into it, and you got to look at the right list. So 32 divided by 27 is a decimal. 32 divided by 8 is 4. So the cubed root of 8 is 2. Comes 2. Now you put 2 in the front, and the 4 goes right there. So write your answer 2. If a variable has a first power, you don't put a power. And then the cubed root of 4a to the second. Okay, and that's how we're going to be orchestrating that moving forward.